guys, today we are going to learn all about problem solving with volume. In today's lesson, you should be able to solve real-world problems involving volume. We're going to use what we know about triangular prisms and rectangular prisms to solve problems in real life where we might need volume. Go ahead and get out your notes and be ready to learn. Determining the volume is just one step in real-world problems. Question 1 says, the neighborhood swimming pool is the shape of a rectangular prism. The pool measures 30 feet in length and 18 feet in width and has a depth of 4 feet. If there are 7 gallons of water in a cubic foot, how many gallons of water are in the swimming pool? To begin, we need to figure out what pieces of information we already know from the problem. There are a couple of pieces of information I know here. First of all, I know the dimensions of the pool. I know the length, width, and depth. I also know that 1 cubic foot is going to equal 7 gallons of water. So it seems like we're probably going to have to do a conversion at the end and take our volume in cubic feet to see how many gallons that is. Next, we need to figure out what I need to know. This usually comes from the last sentence of the question. The last sentence of this question says, how many gallons of water are in the swimming pool? So what I need to know is how many gallons are in the swimming pool. Next, we're ready for our plan and work. Our volume formula is volume equals the area of the base times the height. This question tells me that the rectangular prism, or that the pool is a rectangular prism. So I know that my base is going to be a rectangle. To find the area of the base, I need the base and the height of the bottom of the pool. This would be the length of 30 and the 18 feet width. This tells me that the area of the base is 540 square feet. Now I need to put that into my formula and then multiply by the height of the pool, which is 4 feet. This gives me a total volume of 2,160 feet cubed. Now I've completed some plan and work, and now I need to make sure, did I answer the question that was being asked? And the question says how many gallons are in the swimming pool. And so far I haven't really done anything with gallons. All I've done is found the cubic feet, the volume of feet. So now we need to take that and multiply it by 7 to find out how many gallons. Since I knew the unit rate was 1 cubic foot was 7 gallons of water, I multiplied by 7 to get a total of 15,120 gallons of water. That is the end of question 1. Question 2 says a refrigerator box in the shape of a rectangular prism is 78 inches tall, 48 inches wide, and 24 inches deep. How many cubic feet will the box hold? First, we need to figure out what information we know from this problem. So what I know about this problem is the dimensions of the rectangular prism in inches. I know that the refrigerator is 78 inches tall, 48 inches wide, and 24 inches deep. Now we need to figure out what we need to know. This comes from the question, how many cubic feet will the box hold? It seems like, again, we're going to need to have a conversion here since our measurements are given to us in inches, but the final question wants to know about cubic feet. So I know that there are 12 inches in 1 foot. To get the correct units in the end, since we are doing volume, which is cubic units, I need to change my units right now into feet instead of waiting until the end. So I'm going to take each of my dimensions and divide by 12 to figure out how many feet each dimension is. After converting these units, I know that it is 6.5 feet tall, 4 feet wide, and 2 feet tall. Now I need to use my volume formula to solve for the volume in cubic feet of this box. To get the area of the base, I know that the bottom of this rectangle, or that the rectangle is 6.5 feet tall and 4 feet wide. So I can go ahead and multiply those, or just put them all together in my formula, since I'm just multiplying those two together to get the base, and then multiply it by how deep the box is. This gives me a final volume of 52 cubic feet. Moving on to question 3, the fish tank shown at right needs to be cleaned. The cleaning product instructions state that 3 drops should be put in the tank for every 140 cubic inches of water. How many drops of cleaner should be used? Again, I know that this is a rectangular prism and that I have my dimensions labeled with a picture. I also know that we have another conversion here, that every 140 cubic inches of water needs 3 drops of cleaner. Next, we need to figure out what we're solving for. Again, this comes from the question, how many drops of cleaner should be used? Next, for my plan and work, the first thing that I'm going to do is go ahead and find the volume of this fish tank. So I'm going to find the area of the base, which is 14 times 9. This gives me 126. And then I'll multiply by the height of the fish tank, which is 10. This gives me a total volume of 1,260 cubic inches. As with every word problem, you have to make sure that you have answered the question. And this question wants to know how many drops of cleaner are needed. And I have not done anything to figure out cleaner yet. All I've done is figure out the volume of the fish tank. So now I need to use the conversion that they gave us in the problem to figure out how many drops of cleaner are needed. There's some different ways that you could go about solving this. I'm going to go ahead and set up a proportion since we've done that multiple times this year. With every proportion, you have to match your unit. In the right part of this proportion, I have what the problem gave me. Every 140 cubic inches needs 3 drops of water. Then I know that I'm solving for an unknown amount of drops. This can be your variable. And I matched drops to drops. Then on the top of that side, I put my cubic inches of this fish tank that I know. So I've got cubic inches to cubic inches, drops to drops. Now we need to solve the proportion. As with every proportion, you want to cross multiply and then divide by the one that is not inside the circle. This is going to give me a total of 27 drops. Question 4 is a bit more of a challenging problem, so just stick with me. A layered birthday cake has 3 rectangular prism layers. The base layer, which is the bottom layer, measures 10 inches by 8 inches. Then each layer is 2 inches smaller in width and length as the previous layer, and all of the layers are 5 inches tall. What is the volume of the cake? So what I already know is that this cake is made out of 3 layers, and I know the sizes for each of the layers. And what I need to know is what is the volume of the cake, or how much cake is there? I know that each layer of the cake is 5 inches tall, and then what I know in the problem is how big each layer is. So we're going to go ahead and color code this as I usually do. And I know that the bottom layer is going to be 10 by 8. Then we know that each layer is 2 inches smaller. So the next layer, the red one, would be 8 by 6. And then the final layer would be 6 by 4. Now we just need to find the volume of each of these layers and get the total volume. For each of the layers, I set up my volume formula with the area of the base times the height of that prism, which is 5 inches. Finally, we want the total volume of the cake, so I need to add these 3 volumes together. The bottom layer was 400 inches cubed, the middle layer was 240 inches cubed, and the top layer is 120 inches cubed. This gives us a total volume of cake in 760 inches cubed. You've made it to the end of the lesson. If you've made it this far, let me know. Do you prefer your ice cream in a cone or a bowl? By the end of this lesson, you should now be able to solve real-world problems involving volume. We looked at some problems involving rectangular prisms where we found the volume, and then we might have needed to also add in some conversions. We used proportions to solve some of these conversions, and then in the last problem, we found a composite volume where we had multiple rectangular prisms together. Let me know if you have any questions. Bye, guys.